Everybody to I just want.
I'm really glad to see that there have been a lot of presentations that have related to biodiversity. We're going to talk tonight about where that comes from. My name is Jennifer Katcher, and I'm going to talk about the revolutionary idea of evolution. So to start with, I would like to know, what do you guys think of when you hear the word evolution? Just go ahead and shout it out.
Ridiculous.
Thinking.
Boneless Jesus.
Dinosaurs.
Okay.
Intelligent design.
The right way.
Missing an arm.
Fish with me.
Okay. Well, nobody said this, but natural selection is actually the process by which by which populations change over time. So we start with some genetic variation in our population, and some of that genetic variation is more beneficial than others, and then we can see over time that those beneficial traits increase in the population. And that's due to the environment. What traits are beneficial depends on the environment. So if you change the environment, then you change what traits are beneficial. And because we have so many different environments in our world, that's why we have so many different traits and so many different animals and plants that are very well adapted to those environments. Now, this variation that exists, that happens by chance. These insects, for example, can't will themselves to be a different color. That's just chance. But the process of natural selection is not chance. That is the environment acting on the populations. And if we look, sometimes it's easy to say, wow, these animals and plants are so well adapted, they must have been designed for these environments. But we can take a look at some examples of what we think of as, bad design as well, and we'll see that evolution can explain those too. So here's an example, and our little man isn't eating here, but it does show a picture of, this is normally animated, but it shows that our airway and our entrance to our digestive tract are both located really close to each other, and so we tend to choke. Why is that? Well, we share a very distant common ancestor with another vertebrate, fishes, and when water passes over their gills for respiration, it doesn't matter how it interferes. It doesn't interfere with their eating, but if one were to actually design a human, not just based on existing variation, it would be really nice to raise the trachea so that we don't choke. Okay? So here it is now. We have to have this little flappy thing, epiglottis. Nah, better to just raise the trachea. Another bad design, our eyes. We have a blind spot in our eyes. The red area here, this is our retina, light gathering area, and right in the middle of it, dang it, our optic nerve interrupts it, gives us a blind spot. Squid, hey, they lucked out. They don't have that. They have continuous retina with no interruption. So why is that? Well, we can look a little bit more at the biology of that. But if we look at eyes that were in simpler organisms like this limpet, they basically can only tell light and dark. Some more advanced mollusks like a snail, well, the light gathering cells are arranged in a cup, and that gives some directionality to snail can tell what direction the light came from. So invertebrates like squid, their eyes evolved separately from vertebrates like humans. So there, the cup was flipped in one direction for the invertebrates, but when vertebrates evolved, the cup was flipped backwards. And that's why we have this optic nerve going through the retina. So if one was to actually design an eye, it would probably be better to stick with the squid eye. But next and last is my favorite example of unintelligent design, is what I would call it. And these are hindgut fermenters. These are ruminant animals. When they eat, food enters their stomach, then goes through their small intestine, which is where nutrients are absorbed. But then in this structure called the cecum, a lot of nutrients are released, which is unfortunate because they're released after the area of nutrient absorption. So this nutrient-rich food passes through the large intestine and exits. And how do they actually extract the nutrition out of that? Fecal pellets. They actually have to ingest these again, run them through the digestive tract again in order to extract the nutrients. Okay, and the feces is what actually comes out the second time around. They don't have to eat that. A better design would be the cow. Okay, we maybe have learned that cows have multiple stomachs. So they do have these organisms which break down nutrients in the grass, but that happens before, in these stomachs, that all happens before the nutrients get to the small intestine. So when we talk about evolution, we can say, yes, animals and plants, they're well designed. That accounts for, evolution can account for intelligent design, but it can also account for unintelligent design. Thank you very much.
talk for once. I've been doing some